Geometry lesson 2-2. First bit of information is on perpendicular lines. Perpendicular lines have intersection that form a right angle. Now the description of the symbol is this upside down T, and the reason is because it appears as if they are coming together at 90 degrees. But in reality they don't have to. It could be more like a plus or a cross. But the point is, you have to form 90-degree angles. So here's a 90-degree angle, 90-degree angle, 90-degree angle, 90-degree angle. This is not perpendicular. So you must be careful about that. So if this is perpendicular lines, so is this. That's also perpendicular lines. It's just a little bit different because it's coming at flat. Anytime they come together to form a right angle. Alright? A line perpendicular to a plane. Now this is a little different. You're still having a line, which means it goes on forever, perpendicular, forming a 90-degree angle, but now it's perpendicular to the plane. A line that intersects a plane and a point and is perpendicular to every line in the plane that it intersects. Now, in reality, pretend like this screen right here is the plane. This could be my line that is perpendicular to it, as long as it goes into the screen at 90 degrees. If it doesn't go in at 90 degrees, then it's not. If it comes in at an angle like this, that's not perpendicular to a plane. It must go in. Now it also says that it's perpendicular to every line in the plane. Imagine, if you will, that this plane has all these lines that go through it. And I'm only drawing some of them. There's actually an infinite amount of lines that go through this plane. That's only some. But as long as this is going right through there, that's going to be, and at 90 degrees, then it will be perpendicular to every line in that plane that it intersects. It's perpendicular to all these lines at that one point. Over here, it's only perpendicular to this line and the rest of them that go through it. But as far as these lines I have drawn, that's a perpendicular to the plane because it's containing all those points. We have what we call a biconditional statement. Yesterday, we were talking about if-then statements, conditional statements. A biconditional statement is actually going to have the words if and only if inside them. It's equivalent. That means it's kind of the same, it's equal to writing a conditional statement and the converse, like as if two different statements. The thing that's different about a biconditional, you must always be concerned with, is that it can be both true or false, one or the other. But if it's going to be true, then both the conditional statement and the converse must be true. It can't just be part of it as true. It has to be true for both, which means it has to be true forwards. And remember, the converse reverses things, kind of has to be true going backwards. If it's not true forward and backward, then the biconditional statement is not true. For example, I will wear a rain jacket if and only if it is raining. So in order for that to be true, then the statement, if I wear a rain jacket, then it is raining must be true. And reverse it, if it is raining, then I will wear a rain jacket. That must be true. If both of those are true, then the biconditional statement would be true. Here's another example. Say we have this biconditional statement. Two lines intersect if and only if their intersection is exactly 1 point. Two lines intersect, so here's two lines right here that intersect, alright, if and only if it's exactly 1 point. Is it possible for these to intersect at 2 points at the same time? No, not without bending the lines. Alright, so that's the biconditional. To turn this into a conditional statement, we would need to have an if-then form. So if something, then something else. So here's the conditional. If two lines intersect, which is kind of like saying, oh, there we go. If two lines intersect, that could go there. And if and only if, then they intersect in exactly 1 point. So this is there, but their intersection is exactly 1 point. So I know that's not the same words over here, but it's pretty similar. Their intersection is exactly 1 point. That's where the information is coming to form the conditional statement. Okay? And the converse is going to take the conditional statement and flip it around, so we would end up with if two lines contain exactly 1 point, so that's this part right here, exactly 1 point, then the two lines intersect, then the two lines intersect. So it just reverses it. And if this biconditional statement is true, then both of these would be true. If two lines contain exactly 1 point, then the two lines intersect. Well, if these two lines share a point in common, then they must be intersecting. So that is true. And two lines intersect, they're going to intersect at exactly 1 point. That's also true. So both the conditional and converse are true, which means the biconditional is in fact a true statement.